Shalom class, welcome to Innocent MAPANDA tutorials. In today's lesson we are going to focus on complex numbers, right? So I have extracted a question from November 2020 Zimsec paper 2, section B. It reads, express 3 minus 3 root 3i in exponential form r exponential of I theta, where r is the modulus of the complex number and theta is the argument, right? So let us find r first. To find r, you make use of the formula r is equals to square root of x squared plus y squared. I hope you are following class, right? So x denotes the real value or the real part of the complex number. Y denotes the imaginary part of the complex number. So the real part of the complex number is 3. And the imaginary part of the complex number is minus 3 root 3. So let us substitute accordingly. Right, so I'm going to get 3 squared here. I hope you are following class. Plus minus 3 root 3 squared, something like this. Right, so if you punch this in your calculator, you get 36. So this is equivalent to square root of 36, which is good as 6, and this is the value of r. I hope you are following. Right, we move on to theta. Remember, theta is the argument of the complex number. To find the argument of the complex number, we make use of the formula arctan y divided by x. Remember, y is the imaginary part of the complex number and x is the real part. So I'm going to write this arctan of minus 3 root 3 divided by 3, something like this. So if you punch this in your calculator, you get minus pi over 3. And this is your argument, right? So for argument, there are situations whereby you are required to make an adjustment. Take for example, you are given minus 3 plus 3 root 3i, and you are being required to find the argument of this complex number. You are going to say arctan of 3 root 3 divided by minus 3. If you punch this in your calculator, you will get minus pi over 3. I want you to notice something. 3 minus 3 root 3i is producing minus pi over 3. Minus 3 plus 3 root 3i is also producing minus pi over 3. But the two complex numbers are different and they must produce a different argument, right? So what you need to do is you check the coefficient of I on the complex number. If the coefficient of I on the complex number is plus, it means that your final answer for the argument must be positive as well. So if you get minus pi over 3, you adjust by adding pi, where pi is good as 180 degrees, converted to from radian to degrees. So minus pi over 3 plus pi, your final argument becomes 2 pi or 2 pi over 3. But for this situation, you can clearly notice that the coefficient of I is minus 3 root 3. So if you get the principal value of the argument is minus pi over 3, it is your final answer. Because if you have a negative here, you must have a negative argument. Take note of that, right? So now that we have the modulus and the argument, let us substitute them in the required form. The required form is r exponential of I theta. So on r, I'm going to put 6 exponential of I, open bracket, our theta is minus pi over 3, something like this. If you want to simplify it further, you can write it as 6 exponential minus pi over 3I. Then you are home and dry. I hope you are following class. So I want you to stay focused and stay tuned as we move on to part 2 of the question. Right. Welcome back. We are now on the second segment, part 2 of the question. It reads, hence or otherwise, find all the roots of the equation z to the power of 4 minus 3 plus 3 root 3I is equals to 0. Right, so when solving the nth root of a complex number, you start by moving those numbers minus 3 and 3 root 3I on the right side, so that you make z to the power of 4 the subject first. So z to the power of 4 becomes, if you move minus 3 to the right, you get positive 3 minus 3 root 3I, something like this. This is your first stage. And the good part is 3 minus 3 root 3I is the complex number that we were given in part 1. And we identified that the modulus is 6 and the argument is minus pi over 3. I hope you are following. Right. So what is the way forward? You express 3 minus 3 root 3I in polar form. Remember, polar form is in the form r, open bracket, cos theta plus I sine theta, something like this. So on r, I'm going to put 6, right? Then on theta, I'm going to put the argument plus 2k pi, plus 2k pi. So let me write it like this. Z to the power of 4 is equals to r, open bracket, cos, open bracket, theta, plus 2k pi, plus I, sine, open bracket, theta, plus 2k pi. So whenever you solve the nth roots, make sure you put what 2k pi attached to the argument, right? So z to the power of 4 is equals to r is 6, right? Let me put a big bracket, right? Cos, open bracket, our theta is the argument minus pi over 3 plus 2k pi, something like this, plus I, sine, open bracket, minus pi over 3 plus 2k pi, then I close the big bracket. I hope you are following, right? So the next stage is we want to make z the subject of the formula. So to make z the subject of the formula, we need to raise both sides by 1/4. I hope you are following. So if I raise this by 1/4, you make z the subject. So 1/4 is going to affect 6 as well as this big bracket. Everything, right, is going to be affected by 1/4. The 6 as well as the big bracket. So if 4 and 4 cancels out each other, you will be able to make z the subject of the formula. Right, so what is 6 to the power of 1/4? 6 to the power of 1/4, it gives you 1,57 to 3 significant figures required. I hope you are following. So I'm going to write 1,57 here. First, right. Then applying De Moivre's theorem, this power 1/4 is going to multiply the angle attached to cos as well as to sine. So if I multiply this by 1/4, you get cos, open bracket. Let me start by making this as a single fraction. Something like this before multiplying with the 1/4. You put 3 here, right? 3 into 3, you get 1 times this, you get minus pi. Plus, this is over 1. 1 into this, you get 3 times this, you get 6 k pi, something like this, plus I sine minus pi plus 6 k pi over 3 to the power of 1/4. Right, so if I multiply this bracket by 1/4, it means this 3 becomes 12. So z is equals to 1,57, big bracket, cos, let me start with the 6k, the positive, 6k pi minus pi over 12, where 12 is coming from multiplying 1/4 with this 3 and 4, they give you 12, right? Plus I sine, open bracket, 6k pi minus pi over 12, then you close your bracket. I hope you are following. Right, so I want you to notice something. Z is being raised by power 4. If we have power 4, it means we are going to have 4 roots. And the first root is going to be obtained, right, when the value of k is 0, which we denote as k0, which is our first root, right? So I want to put 0 on k to find the first root. So you are going to have 1,57 here. Then you put your bracket, something like this, right? So take note of something. Your calculator must be in radians, since we are dealing with pi's, right? Then, if we put 0 on k, this 6k pi is going to disappear, leaving you with minus pi over 12. So, cos, right, open bracket, minus pi divided by 12, close bracket, you get 0,966 to 3 significant figures. So I'm going to write here 0,966, right, plus, right, what is sine, open bracket, minus pi divided by 12? You get minus 0,59, right, so plus I minus 0,259, something like this. So if we multiply 1,57 times 0.966, you get 1,52 to 3 significant figures. I hope you are following. This is 1,52 to 3 significant figures. Right, then plus and minus, you get minus. Then what is 1,57 times 0,259? 1,57 times 0.259, what you get is 0,407 to 3 significant figures. So minus 0,407i, and this is your first root. I hope you are following. Right, so the second root is going to be obtained when the value of k is 1. We are now putting 1 on k. So first let me write 1,57, then I put my open bracket. Right, so if you put 1 on k, this 6k pi becomes 6 pi. So 6 pi minus pi, you get 5 pi. So we now want to calculate cos 5 pi divided by 12. It produces 0,259. So I'm going to write 0,259 here. Then if we put 1 on k, you get 6 pi. 6 pi minus pi, it gives you sine pi over 12. So sine 5 pi over 12. 5 pi divided by 12, you get 0,966. So plus 0,966i, something like this. Right, so 1,57 times, right, 0.259. You get 407 plus 1,57 times 0.966. What do you get? 1,52i. And this is your second root. I hope you are following, class. Right. We move on to K2, which is our third root. So you start by writing 1,57 first, then you put open bracket. We now want to find the third root when k is 2. So if you put 2 on k, you get 12 pi minus pi, which gives you 11 pi over 12. So cos 11 pi divided by 12, it gives you minus 0,966. Then sine, right, 11 pi divided by 12, what do you get? 0,259. So plus 0,259i, something like this. I hope you are following. Right, so 1,57 times this, you get minus 1,52. Right, then 1,57 times 0,259, you get plus 0,407i, and this is our third root. So the last root is going to be obtained when the value of k is 3. I hope you are following. So I'm going to start by writing 1,57, which is 6 to the power of quarter. Putting 3 on k, you get 18 pi. 18 pi minus pi, you get 17 pi. So here we want to identify cos 17 pi divided by 12. You get minus 0,259. Then we now need to identify sine 17 pi divided by 12. What do you get? Minus 0,966. Minus 0,966. Then you put I, something like this. So 1,57 times negative 0,259, you get negative 0,407. Then here you get 1,57 times negative 0,966, you get negative 1,52i. Then you are home and dry. So this is how you calculate the 4 roots of the equation. Stay focused as we move on to the final part of the question. Right, we are now on the part 3, which is the last part of the question. It reads, use de Moivre's theorem or otherwise to show that tan 5 theta is equals to the given identity on the right side, 7 marks. Right, so the first thing to note here is tan theta is good as sine theta over cos theta from the identity. Right, so if you have tan 5 theta, it means tan 5 theta is identical to sine 5 theta divided by cos 5 theta. Then you apply de Moivre's theorem. Right, so cos 5 theta plus I sine 5 theta is good as cos theta plus I sine theta, all raised to the power of 5. I hope you are following. So let cos theta be x, sine theta be y. So on cos theta I'm going to put x, on sine theta I'm going to put y, so that you get yi to the power of 5. Then you perform the binomial expansion. Right, so if 5 is the power from the Pascal triangle, the coefficients of expansion are 1, 5, 10, 10, 5, 1. Something like this. These are the coefficients of expansion for any bracket raised by power 5. I hope you are following. Right, so what I'm going to do is, I'm going to write 1 here, plus 5, plus 10, right, plus another 10, right, something like this, plus 5, plus 1. So I've aligned the coefficients, right? So let me start with 1. If I put x here and yi, this x I'm going to raise it by 5, yi I'm going to raise it by 0. If I put x here and yi, it means the powers of x are now being reduced whilst the powers of y are increased. So we now have 4 here and 1. Right, then if I put x here and yi here, we now have 3 and 2. If I put x here and yi here, we now have 2 and 3. So we are reducing the powers of x whilst increasing the powers of yi. I hope you are following. So if we put x here and yi here, we now have 1 and 4. If we put x here and yi here, it gives you 0 and 5. I hope you are following. Right, so yi to the power of 0 is good as 1. And if we multiply 1 times x to the power of 5, our first term is going to become x to the power of 5. I hope you are following. Right. Then plus 5x to the power of 4 yi. Since yi to the power of 1, it gives you yi. I hope you are following. Right. But take note of this third term. If yi is raised by power 2, something like this, it gives you y squared, I squared. But remember, I squared is good as minus 1. So y squared times minus 1, you get minus y squared. So on this one, this positive sign become negative. So I'm going to write as 10 x cubed y squared, since I squared is minus 1. I hope you are following. Then we move on to the fourth term. Let us also target this bracket yi cubed. You get y cubed, I cubed. What is I cubed? I cubed is good as I squared times I. So I squared is minus 1 times I. You get minus I, which gives you minus y cubed I. I hope you are following. So this plus becomes negative. So 10x squared y cubed, but we'll be having an I. Something like this. Then we move on to the second from last bracket. Let us also target this yi to the power of 4. If yi is raised by 4, you get y4, I4. And I4 is I squared times I squared, which is minus 1 times minus 1. You get 1, remaining with y4. So the positive sign is going to remain as it is. Then you write this 5. X to the power of 1 is x. Then you have y to the power of 4, since I to the power of 4 is good as 1. I hope you are following. We now move on to the last. Let us target at yi to the power of 5. You get y to the power of 5, I to the power of 5. I hope you are following. What is I to the power of 5? It's I squared times I squared times I. I hope you are following. So I squared is minus 1. So it's more of minus 1 times minus 1 times I. You will be left out with the I. Since minus 1 and minus 1, they give you a plus. I hope you are following. Y to the power of 5, I. Since x to the power of 0 and 1, they produce 1. I hope you are following. Right. So, let us go back. We said before that tan 5 theta is identical to sine 5 theta divided by cos 5 theta, right? So you can clearly notice that from De Moivre's theorem, sine is representing the imaginary part of the complex number. Then cos 5 theta is representing the real part of the complex number. So on the numerator here, I'm going to put terms, right, with the I. Then on the denominator, I'm going to put terms without I. So the terms with I, we have 5x to the power of 4y. This is the first term in I. Another term in I, we have minus 10 x squared here. Then we have y cubed here, right? Then another term in I, we have plus y to the power of 5, something like this. We are done with the numerator. Then on the denominator, I'm going to put the real parts without I. We have x to the power of 5, right? What else do we have? We have minus 10x cubed y squared, and we also have plus 5x y to the power of 4, something like this, right? So after doing that, you go back to the substitution. We mentioned that let cos theta be x, let sin theta be y. So on x, I'm going to put cos, on y, I'm going to put sine. So you obtain 5 cos to the power of 4 theta, sine theta, minus 10 cos squared theta, sine cubed theta. I hope you are following. Plus sine to the power of 5 theta, something like this. Then on our denominator, you get cos to the power of 5 theta minus 10 cos cubed theta sine squared theta plus 5 cos theta, right, sine to the power of 4 theta, something like this, right? So how do you create a tan? To create a tan, you need to divide everything by a term in cos. So you find the highest power of cos that we have. Comparing both the denominator and the numerator, you can clearly notice that the highest power of cos is cos to the power of 5. So I'm going to divide everything by cos to the power of 5 theta. So I'm going to start with the numerator. Cos to the power of 4 theta sine theta is going to be divided by cos to the power of 5 theta, something like this, minus 10 cos squared theta sine cubed theta to be divided also by cos to the power of 5 theta, plus sine to the power of 5 theta divided by cos to the power of 5 theta. This is our numerator. Then on our denominator, we have cos to the power of 5 theta divided by cos to the power of 5 theta minus 10 cos cubed theta sine squared theta divided by cos to the power of 5 theta plus 5 cos theta sine to the power of 4 theta divided by cos to the power of 5 theta, something like this. I hope you are following, class. Right. So you can clearly notice that if cos to the power of 4 theta cancels out with the cos to the power of 5 theta, you'll be left with the cos theta. So this term becomes 5 tan theta. Since sine theta over cos theta, you get tan theta. I hope you are following, class. Right. We move on to the next term on the numerator. Cos squared into cos to the power of 5 theta. You'll be left with the cos cubed theta. So sine cubed theta divided by cos cubed theta, you get tan cubed theta. I hope you are following. Then the last term on the numerator is going to produce tan to the power of 5 theta. Since sine to the power of 5 theta divided by cos to the power of 5 theta, you get tan to the power of 5 theta. So we are done with the numerator. I hope you are following. Then cos to the power of 5 theta divided by cos to the power of 5 theta, you get 1 minus this cos cubed into cos to the power of 5 theta, you get cos squared theta. Where sine squared theta divided by cos squared theta, you get tan squared theta, something like this. Plus cos theta into cos to the power of 5 theta, you get cos to the power of 4 theta, which gives you 5 tan to the power of 4 theta. Then you write shown. You get your 7 marks. This is how you're supposed to do. Thank you for watching. I kindly ask you to invite more subscribers to our channel so that many candidates outside there can benefit from innocent MAPANDA tutorials before their final exams. Thank you, my viewers, and thank you for your support. I am very humbled to have you on my channel. Till we meet again, shalom.